All right, here's the last video for this summer homework lecture series, and some ideas from Algebra 2 about logarithms that you at least need to be familiar with. Now, I know that logarithms is a pretty challenging topic if you're in Algebra 2 or math analysis, that logarithms can be pretty challenging, and luckily, a lot of the really difficult stuff about logarithms we won't cover, but we will be using the idea of what a logarithm is quite a bit this year. But a lot of the computations expanding, condensing logarithms, how to move the logarithm graph around the coordinate axes, stuff like that we won't really use in this course. It's used in calculus though. But you need to know what a logarithm is. Okay, so we'll talk about what exponential functions are, how they relate to logarithmic functions, and you'll need to be able to find the log of different values and also solve equations that involve logarithms. That's about all that we'll do in this class. Okay, so an exponential function is where the variable is in the exponent. Okay, so x is in the exponent, which is why it's called an exponential function. Now what that does is, since 2 to the x, you're multiplying 2 by itself x number of times, what you have is something that grows really quickly. So it goes 1, 2, 4, 8, 16, 32, and you'll notice that it begins to grow very, very rapidly as x increases. Okay. Now the fact that these are all spread out and these are really close together. In fact, these are really close together. That the fact that the small numbers are close together and the big numbers are really spread out, we're going to use that because sometimes our data sets are kind of the reverse effect, where the small numbers are small and the bigger numbers are really spread out. If you think about values of homes, there are lots that are small, and then there are a few that are really spread out on the upper end. Okay, incomes as well. You have a few that are smaller, a lot that are smaller, and then you have a few that are really spread out on the upper end. Okay, so we'll use the reverse of that, which is how logs will become useful to us. Okay, a logarithm is the inverse of an exponential function, where now the x's are really close together here and spread out down here, and the y's are are very linear, which is useful to us in this class. Okay, so understanding that a log is the inverse of an exponential function is very useful to us. Let's talk about how you take the log of different numbers. Here, the log base 10 is what we'll almost primarily use in this course, as log base 10. We won't do very much in other bases, occasionally base e, but usually it's base 10. Now, let me pull up my calculator real quick. Let me move this over. Okay, now I hope that you're aware that the log button is right here next to the 7. Okay, so to find the log of 2 is hit 2, enter. Okay, and what we get is 0.301. Okay, now let me kind of emphasize what that means. Okay, that means that 10 to the 0.301 power is equal to 2. Okay, so that's the exponent that 10 would need to be raised to get the value of 2. Okay, the log of 5 is 0.69897. The log of 10 is 1, because 10 to the first power is equal to 10. Okay, and I'm going to do the rest of these on my calculator. But I have log of 2, I get 0.301. The log of 5 is 0.6, I'll say 699. The log of 10 is 1. The log of 35 is 1.544. The log of 90 is 1.95. The log of 120 is 2.079. The log of 180 is 2.255. The log of 350 is 2.54. Okay. Now again, I'll point out the fact that this is close together. It gets pretty spread out down here, but yet these values are, pretty linear, where you kind of are counting up by a certain number. That aspect of logs will be really useful to us. Okay, we'll see examples where our data is curved because one of the values or both of the values are a little more of an exponential relationship, and so we'll need to kind of take logs of one value or the other value, and we'll look a lot more in depth in that this next year. But I want to make sure that you have a foundation we can build on with logs of knowing what logs are. Okay. The other thing that we'll need to do in this class is solving some logarithmic equations. Okay. Now, keep in mind that if there's no base written here, it's base 10. Okay, and we'll be using some laws of exponents that I haven't actually addressed in this video. I'm hoping you're familiar with it. If not, then go ahead and Google laws of logarithms, and I'm sure there's web pages about it or videos about it you can watch. So I'll solve this by taking both sides to the power of 10. Okay, and keep in mind that if this number is the same as the base of your exponent, these will cancel out, and I'm left with x is equal to 10 to the fourth power. Okay? Another way of thinking of that is probably a better way of thinking about it is that 10 to the fourth power is equal to x, and so x is 10 to the fourth power. Okay? Which is 1 with 4 zeros. Okay? So 10,000 is the answer. Number 2, x plus 8.2 is equal to log of 46.8. All right. Well, now the log of 46.8 is just a number, the log of 46.8 in my calculator, and I get 1. I should do it like 3 decimal places, but this is only to 1, and so I'll keep it at 1 and do 1.7. So x plus 8.2 is equal to 1.7, a very simple linear equation. I will subtract 8.2 from both sides. I have 1.7 minus 8.2, and I have x is equal to negative 6.5. Okay, this one with natural logs where the base is e. Now, the natural log of 99.1 is just a number, so ln 99.1, plug that in. So I have ln of x is equal to negative 9.1 plus 4.596. You know, I should do to 1 decimal place because 9.1 is 4.6 then. Okay, now negative 9.1 plus 4.6, and I get the natural log of x is equal to negative 4.5. Now, again, what the natural log is, it's e to what power equals x. So I can simply think of that as x is e to the negative 4.5 power. If you want to think about raising both sides to the power of e, I'm not sure which way you've been taught to think. But x is e to the negative 4.5 power, and I get x is equal to 0.0111. Okay, finally a different base 2. I'm not sure why I chose base 2, but whatever. 19 plus 4.4. The log base 2 of x is 23.4. This is 2 to the 23.4 power is equal to x, is what it means. If you want to think about raising both sides to the power of 2, you can. But x is equal to 2 to 23.4, which I'm probably going to overload my calculator. Oh, it didn't. And I have 1,106,834.62. So 11,068,834.62 is what that's equal to. Okay, so solving some logarithmic equations or equations with logarithms in them will be useful to us next year. Okay, take a second, summarize the ideas in this lesson, write that in your notes, and then go ahead and try the practice problems dealing with logarithms.